Hi, welcome to the next installment of AT Math 10.8, Permutation and Computations. We're going to take our time with this one because there's lots of stuff to talk about. Basically what we have here is we have what's called the fundamental counting principle, and I'm just going to show you rather than go through the terms, because I actually tried to make a copy of this and went through all the terms and it didn't sound right to me, so let me just put it in basic terms. The counting principle is simple. Take, for instance, a florist has two kinds of vases, two kinds of plants, three kinds of flowers. If they want to figure out all the different possible combinations in order to figure out how many different combinations you possibly can, you have two vases, two plants, and three kinds of flowers. So you would take 2 times 2 times 3, and that would give you 12 possible. Notice here how they have these different combinations, and they'll say there's 12 possible combinations. Well, the fundamental counting principle says 2 times 2 times 3. Makes it easier. So the first way, you can draw them all out, different tree diagram if you like, or you can just say 2, 2, and 3, 2 times 2 times 3 is 12. Either one will work. Now for the second one, a compound event means there's more than one event happening at once. Suppose for instance you have to flip a coin and it has to land heads, and you have to roll dice and it has to be a 3. So the chance of those two things happening together is a combination. For instance, if you're at the racetrack and you're betting on the horses, sometimes you might bet on 2 races and you have to bid the winner on, let's say, the 3rd race and the 4th race. The chance of calling both races right are very small, but the payout is larger for that reason. They might pay you 20 to 1, 30 to 1, 40 to 1. Of course, the odds of you actually getting it might be 50 to 1 or 100 to 1, so there's the idea. Combination is a grouping of outcomes which the order does not matter, or permutation is an arrangement of outcomes which the order does matter. Finding combinations of permutations. For instance, if they said that a street vendor sells cashews, peanuts, and almonds, how many different ways are there to mix each kind of nut? So they list all the possibles here. You have cashew, peanut, peanut and almond, almond and cashews, peanut and cashews, almond and peanuts, and cashew and almonds. They all switch places. Now these are the 6 possible if order matters, but if the order of outcomes is not important, I can get rid of the ones that are simply duplicates. Here's what I mean. Notice where it says peanuts and cashews, and before I had cashew and peanuts. Well, it's still cashews and peanuts, or peanuts and cashews. We just flipped the title. They're still the same things. Where if I say peanuts and almonds versus almonds and peanuts. If I said to you, hey, you want peanut butter jelly? You're like, no, I don't want that. Well, how about jelly and peanut butter? You know, it sounds different, but it's actually I just switched the titles up some. So basically there's only 3 types of actual combinations he can sell for that. And we'll get to more of that in a minute. Karen's painting her bedroom. She has orange, green, blue, and purple paint. She plans to use one color as a base coat and stencil a design with another color. How many different ways can she do this? So based on this, let's take a look at what we have here. So basically they're saying they could use one coat as the base. So let's say they're all orange. The base of the wall is orange, or the base of the wall could be green. Base of the wall can be blue. Base of the wall can be purple. So it's going to be one of those 4 choices. And then she has 3 other options to choose from. So if she picks orange as her wall color, she can pick purple, blue, or green for her stenciling. Why doesn't she pick orange? Well, orange stencil and an orange wall, you're not going to see the stencil because it's going to be invisible. So this is the 12 different options she has. The order of outcome is important because one color is painted on top of the other. So this involves permutations, meaning that combination, it does make a difference which one comes first, which one comes second. So there are 12 different ways that Karen can paint a room. Now, a factorial of a number is the product of the number and the natural numbers less the number, blah, blah, blah. Look, the factorial, let's say, of 5 means 5 times 4 times 3 times 2 times 1. The factorial of 3, 3 times 2 times 1. The factorial of 10, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Example. Suppose you want to make a 5-letter password from A, B, C, D, or E without repeating the letter. So you have 5 choices for the first letter. So choice A, you have 5 choices. You can pick A, B, C, D, or E. So let's say I pick C. Alright, well C is no longer an option. So my second letter, I only have 4 choices to choose from. So the first one I had 5 choices. Let's say I pick A. I only had 4 choices total, and now I've used A. Well, now for my third letter, I only have 3 choices. Let's say I'll pick an E. Okay, so I get rid of E. Now I have 2 choices left for B and D, so I'll say B. Leaving only 1 choice, D. But to find out how many different possibilities I had, 5 times 4 times 3 times 2 times 1, well, 5 times 4 is 20, times 3 is 60, times 2 is 120. So there's 100 different possible combinations for 5-letter password using A, B, C, D, or E. Now let's do the same thing again, but this time we're only going to do 3 letters. Now there's a slight difference. Well, for the first one, I have 5 choices again. So 5 choices for the first one. Let's say I'll pick B. Well, B is no longer an option. Now I have 4 choices left, so I'll go ahead and pick one, doesn't matter, E. Alright, and now I only have 3 choices left. Let's say I'll pick an A. Well, 5 times 4 times 3. 5 times 4 is 20, times 3 is 60. So basically, I had 120 choices when I had 5 letters. I have 60 different choices when I have 3 letters. Now, the permutation side is like this. They're saying, well, for 5 possible combinations, it's 5 with the exclamation point, meaning 5 times 4 times 3 times 2 times 1. And for the second one here, because I had 2 choices remaining, in other words, I didn't use 2 of the numbers, the bottom is 2 exclamation point. Let me make it easy. 5 exclamation point or 5 permutation is 5 times 4 times 3 times 2 times 1. This is 2 times 1. Notice how 2 and 2 can cancel, 1 and 1 can cancel. 5 times 4 times 3. The easier way I'd tell you to do is this. I would say you have 5 choices. Alright. You are going to, let's say, use 3 of them. So basically 3 numbers starting with 5. So 5, 4, and 3. And that's how you do. Let's say you have 8 different numbers to choose from. And you have to pick 4. So 1, 2, 3, 4. 8 times 7 times 6 times 5. That's the easier way if you ask me. But whatever way makes you happy. If you want to put this and then work them out, be my guest. And this is the actual technical side of it. It means the same thing. NPR means the number of permutations and the rate. And then the permutation of N and N minus R, the difference, the permutation. I think it's more complicated doing this, but feel free if you wish. Here's what I'm saying. A club will choose a president, a vice president, and a secretary. So you're picking 3 positions out of 8 people. Well, the first, let's say you vote for a president first. So you have 8 different choices. And let's say Bill was voted president. Okay, fine. Well, now Bill's not an option because Bill's already the president. So you have 7 choices left for vice president. So you pick out of 7. Then you have, that person's gone. Let's say it's Gene is vice president. Then you have 6 people left. So you have 6 people. Let's say you vote Sarah as secretary. And that's what you would have. So 8 times 7 times 6. Or simply 8 possible choices. And there's going to be 5 people that won't be chosen at all. So 8 exclamation point over 5 exclamation point. You can work it out. 8 times 7 times 6. And all this, you would still have times 5 times 4 times 3. But on the bottom you'd have 5 times 4, and they'd all cancel. So really, at the end of the day, this is all you're doing. And I think doing it in the way I told you up here is a lot easier. It's up to you, though. Lead brings 7 CDs numbered 1 through 7 to a party. How many different ways can you choose the first 4 CDs to play? Well, how many CDs did he have to begin with? 7. So he's got 7 possible. Once he chooses one, he has 6 possible after that. Then he only has 5 to choose from, and then 4. Unless, of course, he allows himself to repeat. But who wants to repeat a CD at a party? I mean, really. So 7 times 6 times 5 times 4, I think that's easier. Or you can do this method with 7 permutation over 3 permutation. Whatever makes you happy. Either way, you're going to get 840, either by doing this or this, whichever. Following for combination involve factorial. Now, this is one difference here. In this case here, you see a club will form a 3-person committee from a list of 8 people. How many ways can the club choose 3 people? Well, there are 8 people to choose from. So, okay, you have that. So the first person I'm going to have is 8. And then I'm going to go ahead and have 7. And then I'm going to go ahead and have 6. So we know this. Not only that, though. You have to remember, well, actually we'll do it the long way this time. Times 5, times 4, times 3, times 2, and times 1. Now what they're saying here is you have to choose 3 people at a time. So basically this part's going to be the same, which is you're going to have the remaining 5 times 4 times 3. Oh, I guess I should make that a dot. Whoops. 5 times 4 times 3 times 2 times 1. However, the one difference is that you're going to have a 3-person committee. So it's not just picking one, you're picking 3 at a time. So by removing 3, you're kind of changing the whole skew of things. Look, to make life easy, you can still go ahead and minus 5 to get rid of the 5, 4, 3, 2, 1. But also because you're choosing 3 people, it's also going to be 3 times 2 times 1 over here. Which basically means you just have 8 times 7 times 6. And this is 6, which cancels and leaves you 56. If you don't truly follow this one, I'm not going to lose a lot of sleep over it. This is a fairly advanced system for combinations. You're basically saying you have to choose 3 different groups, but each group is 3 people, and that's why there's only 56 possible combinations. But feel free to make up 8 names and run all the possible combinations if you wish, but I think this is faster. There are 11 different cereals for sale at a grocery store. How many different ways can the shopper select 4 different cereals? Now, there's the difference. If it was simply 1 cereal at a time, that'd be one thing. In other words, if it was just 11 cereals to choose from and I said pick 4, one individual, I'd say no problem. That'd be 11 times 10 times 9 times 8. You know, if you just say I'll pick, let's say total, then I'll pick Frosted Flakes, then I'll pick Oat Bran, then I'll pick Fruit Loops. But they're saying they want you to pick 4 different cereals at a time. In other words, they want they want a block of 4. They want those 4 as a combination and this 4 as a combination. You're basically getting rid of any duplication, much like the almond and cashew example. Simply put, you can put the times 7, times 6, times 5, but those are the extras, you can cut them off. All you have to add is because you're picking 4 at a time. You also have to add 4 times 3 times 2 times 1. Understanding, remember, that this over here was the times 7 times 6 times 5, which are just going to cancel each other anyway, so I wouldn't even give us the next thought. 4 times 3 times 2 is 24. So basically what you have is 11 times 10 times 9 times 8 all over 24, which is going to give you 330. That's it. We'll do some examples in class. This one you might need some help on. So even if you watch the video here and went back a couple times, I'll help you with the remainder. So thanks again. Bye.